Hi, welcome to the video on how to write electron configuration for transition metal ions. So when we say ions, we mean something with a charge. If it's a plus charge, it's a cation, and if it's a minus charge, it's an anion. And with transition metals, just like with most metals, for the most part, they're going to be cations. They're going to have a positive charge, which means that they have lost electrons to have a positive charge. So you have to lose electrons to get a positive charge. Now, when I'm talking about transition metals, specifically, I'm talking about the elements in the D block. So in the D block of your periodic table. Okay, so in the past, when we have written electron configurations for any ions, whether it's cation or anion, we just counted the number of electrons, and then we either filled it up using the atomic orbitals or using the blocks in the periodic table. But for transition metals, like you often will see, they are different. And mainly the reason why they have the difference is because the Ns and the N-1d orbitals are really close in energy. So, for example, the 4s and the 3d are really close in energy. So, because they're close in energy, those energy levels can sometimes shift and change places. And that's what happens when we form cations. It turns out as soon as you remove an electron, these energy levels shift, and then the Ns will become higher than the Ds. So, because of that, what we do for transition metals, the best way to write their electron configurations of their cations is to first write the electron configuration of the neutral metal. So in the case of iron, which is here, it's the D6, right? So that'll be 3d6, 4s2, 3d6 is how it ends, okay? So it's a D6. All right, so this is what its neutral electron configuration is. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Now, if I want to write the electron configuration for iron plus 1, what I'm going to do is I'm going to remove electrons from the neutral. So I write the neutral configuration, and then I remove electrons from the neutral configuration, starting with the Ns. So remove from the Ns first. Now, for iron plus 1, I need to remove one electron, right? Because it has a plus 1 charge. So what I'll do is I'll remove my one electron from the 4s. The 4s has 2 electrons in it, so I'm going to cross that out and make it 4s1. And so my electron configuration for neutral, for iron plus 1 will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d6. Notice it's pretty much the same thing except for I remove my electron from the s. Now typically we would think to remove from the d's first, but again, transition metals have the exception. So you only have to do that for these types of metals. All right, let's look at the next one. For iron plus 2, I'm going to remove 2 electrons. So again, I'm going to start removing them from the 4s. And there are 2 electrons here. So in this case, my entire 4s cancels out, and that gives me 1s2, 2s2, 2p6, 3s2, 3p6, 3d6. And then finally, for Fe3 Plus, I'm going to remove 3 electrons. All right, so again, I'll start my first 2, I'll remove from the 4s, and I have 2 of them. I have 1 more to remove, then I'll remove from the D. So that goes from 6 to 5. So I took away 2 from the 4s and then 1 from the 3D, so I can remove my 3 electrons. And now this is my electron configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. Okay. So to show you what overall that looks like, these will be the electron configurations for your transition metals. Here they are. Okay. This is them all written out. So take a moment and to look at that. So once again, for transition metals, draw the neutral configuration first, and then remove the number of electrons. The number of electrons you remove will correspond to the charge, and you remove them starting with the Ns and then due to the N-1d. And again, this only works You only have to do that for these metals in the middle block here. You don't have to do it for group 1 metals or any of the other metals, just the ones in the middle. All right, I hope you found this video helpful. Have a quality day.